Good morning, lovely 12s. Right, buddies, it is our second online lesson today, or your first online lesson if you're my other year 12 class. So, yeah, hypothesis testing online. How exciting! Yeah, so a class who I've not done an online lesson with yet, I'm going to, on your homework, attach the first lesson of hypothesis testing as well, because you might want to review that, because I guess the other class has the benefit of being able to pause and play and look back at it, and so I want to give you that chance too. I'm still in self-isolation until next Friday because the stupid contact tracing app got me, so apparently I was near to someone with COVID. So yeah, that's the story for the ones of you who didn't already know it. So everyone together, here we go, my lovelies. Last lesson we did one-tailed test, and we did hypothesis testing for one-tailed tests. That's what we did last lesson. Now, this is one of the hardest topics in stats, I think. In my head, this is the hardest topic that we do all year, and it took a long time to explain it, and that means that you haven't had really enough practice yet. So, whilst I'm rambling right now, my goal is to go quickly through this one example only, and to give you as much time as possible just to practice today. So what I've done is I've gone online, or I've gone on the textbook, and I found this question from the mixed exercises, which I think is a pretty hard one, but is still it's a pretty hard one, but it's still quite doable. That's why you chose it. So there we go. So here we go. Yeah, your title is One-Tailed Test. Now, here we go. Let's have a little try. Okay, it says, a marketing company claims that Chesley cheddar cheese tastes better than Cumnold cheddar cheese. Right, so I guess that's a place too. Cumnold cheddar cheese. 5 people are chosen at random um, as they've entered a supermarket, and they're asked to say which they preferred. 4 people preferred the Chesley cheese. Test at the 5% level of significance whether or not the manufacturer's claim is true. State your hypothesis clearly. Okay, the manufacturer's claim is true. So I presume that means that we are the manufacturer. We work for the manufacturer. Oh, and indeed we are. We're the marketing company. So, yeah, that's who we are in this whole scenario about cheese. We're the marketing company, and we think that Chesley cheese is better. So, that's us. We're the Chesley people. Cool. So, let's lay out this hypothesis test, remembering that what a hypothesis test is that we're just trying to determine if our cheese is better than the other cheese, or if our drug is better than the previous drug, or if our iPhone manufacturing is with our new machine is better than the iPhone manufacturing was with the old machine. That's what hypothesis tests do. So step 1 in all of them, buddies, do you remember? If you said lay out your random variable, you're absolutely right. So step 1 is always to define what big X is. Boom, boom. Now with big X, what you're going to be dealing with is it's a counting variable. And so we're going to be counting something. If we're the marketing company for Chesley Cheese, what is it that we're going to be counting? That's right! We're going to be counting the number of people, because it has to be a counting one, who preferred Chesley cheese. Oh shoot, I spelled that wrong because I was talking over it. Preferred preferred Chesley cheese. Cool. So that is what we are going to be counting. Anyone remember what step 2 is? That's right, lay out the random variable, or lay out the distribution, I should say. So x then, in year 12 it's nice and easy because there only is one distribution that we know. It's the binomial distribution. And how many people are we going to ask? It's B and P. How many people are we going to ask? Right, 5 people. What's the chance of success? Don't know yet. P. Cool. So that's perfect. Okay, step 3, what's that going to be? That's right, hypothesis tests. Hypotheses. H naught and H1 are our 2 hypotheses that we're gonna lay out here. And let's do it. Before I move on, there's something really important that I want to note, and that's this. Can you see that this is worth 7 marks, this question? Yeah, these questions are worth so much. That's why it's kind of high stakes, that you're good at them. But if you look at it, like after we finish this, we've already got like 3 out of the 7 marks. So Yeah, laying them out's really important. So just do your best to remember the steps. I know hypothesis testing is a bit of a pain, but lay out the random variables, set the distribution, hypotheses test, and then carry out the test. That's kind of how we do it. Okay, anyway, H naught, the null hypothesis. Well, my buddies, the null hypothesis is the default case. So say that people were neither here nor there. We have two types of cheese. We've got Chesley cheese and we've got Comnold cheese. Say that our cheese was no different to the Comnold cheese, that they taste exactly the same and and that they are the same price. What would be the chance that someone would pick up our cheese then? Yeah, 0.5. You're right. It should be 0.5. If our cheese is neither here nor there, and everything else was kept the same, it would be like a 50-50 chance if you'd pick ours or the other one, because you wouldn't care because they're the same. So that's kind of how that goes. So probability then, 0.5. What do we feel like, though? We're the marketing company for Chesley. What do we think about our cheese? That's right, we think our cheese is better. So we think the probability is actually better than 0.5. And doubly, the reason why we think that, buddies, is because if you think about it, 4 people out of 5 did like our cheese better. So we have reason to believe our cheese is better as well. So that's brilliant. Now here you go for another mark. Here we go. You have to write down the stuff to start the hypothesis test. Always this. Always assume H naught is true. Okay, so we're taking the default position as the one that's true. And if H naught is true, then X is a binomial distribution still with 5 trials, but the chance of success though, my buddies, is not 0.5. We can actually put P in, okay? It's always just going to be binomial because on year 12 it's always binomial, and it's binomial just because it meets the 4 criteria. So there you go. Perfect. Now it's time, my lovelies, to try to figure out if our cheese is actually better or not statistically to the, oh, I didn't write down the significance level, to the 5% significance level. Well, here's what you do. Draw your sticks out, like that, big long sticks. Underneath goes the number of successes, or the number, yeah, it is the number of successes, the number of people who liked our cheese. 0 is the minimum, 5 is the maximum, because there was 5 tries. If it was a 50-50 chance, the kind of average of this then would be 5 times 0.5, which is 2.5. So we would expect 5 times 0.5, we would expect 2.5 people to pick our cheese, but 4 is what was observed. So here's what you do next, my buddies. We're going to be using the critical region method here first, and let's do it. Well, 5% significance. What we're going to do, we think it's more than, so we're going to test at the upper end here, and we're just going to kind of scratch out a little area like that, remembering not to color hard, because you're going to have to write out underneath that. That is 0.05 because that's the significance level. Cool? All we're going to do now is trial and error into our calculator. We want to know we'd like to know then if, like what number belongs here and what number belongs here. See what I mean? So what's the first one we'd reject? What's the first one we would accept? So what do you got to do now? And I know that this is awkward because it's not a video, it's just capturing my screen, but get your big calculator out, push menu, choose 2 for stat. After you're in stat, my buddies, choose distribution, which is F5, choose binomial distribution, which is F5, and we're doing B, C, D, the cumulative distribution, okay? Cool, should say variable. Now, X is the one you just have to guess. I'm going to guess 3. The number of trials is 5. The chance of success is 0.5, push equals. Okay, for 3, I got 0.81, which is nowhere near the 0.95 that I should have got. 0.95, because if this is 0.05, our calculator does less than or equal to, and I'm looking for one that's inside the green, I've got to be above 0.95, because that would mean that I'd be in the green, because the answer to that, like one take away that, would be inside the green section. So yeah, that wasn't the right number, so 3 was wrong. Back into the calculator, boom, try 4, and 0.96. So 4 is our ticket, buddies. So here's what we're going to do. We need to calculate downwards, so let's calculate this. It's going to be the probability of x being greater than or equal to something is going to be 1 take away the probability of x being less than or equal to something. Now, I want my answer to this question to be under 0.05, so I'm going to use the 4 here. Cool. Which means, my buddies, that I'm gonna have to have, in this one, a 5. Oh, weird, which is the end of the entire range. That's alright, though. Don't worry about it. That's cool. So, in your calculators, then, what you're gonna do, deploy little calculator. 1 take away, and the number was 0.969, giving me 0.031. 0.031. So the number here, this red, oh, this is funny, this one. See that red line there? That red line there, which makes an answer of 0.031, actually, buddies, isn't there because it's representing 5, right? But 5's already there, which means it's quite weird. This red line is actually here at the end with the 5. So we're at the very end. So 5 is the only number that we'll accept that's inside the green region. Because when we bound it, that means this has to be 4. So when we bound it, check what happens. X is greater than or equal to 4, which means it's going to be 1 take probability of x being less than or equal to 3. Okay, big calculator for the 3. 3 equals 0.8125. So 1, now little calculator, take away 0.8125 equals 3/16, which equals 0.186. Okay, 0.186. So in other words, 5 is inside the green region, which it is, and 4 is not. So we've bounded our thing. 5 is enough to say for sure our cheese is better, but 4 isn't quite enough. We're not 95% sure our cheese is better if only 4 people have it. So what we've done then is we've made a critical region. So let's do it formally, as we're only doing one example, so let's do it formally. So the yeah, our critical region, what we're going to accept is anything more than 4. So the only way that we know our cheese is better is if 5 people say it's better. That's the only way that we can be 95% sure. Now, how many people preferred Chesley? 4. So it's not inside the critical region. So here's what we're going to do. We're going to write our conclusion now. So H naught is accepted. Okay, H naught is accepted because we are not 95% sure. We are not, how am I going to write this? We are not 95% sure. I'm going to write it different. Yeah, we're not 95% sure that our cheese is better than the Cumnold cheese. Cumnold cheese. Does that make sense, guys? So since only 4 people out of 5, so 80% of the people picked our cheese, where it should have only been, yeah, 80% of the people picked our cheese, so our cheese probably is better, but before we run an ad campaign to say, oh, Chesley cheese is way better than Cumnall cheese, and potentially get into trouble for saying false advertising or fake news, as Donald Trump says, and all sorts of stuff like that, before we get in trouble for that, we're not 95% sure that that's the case. So what are we going to do? We could run a bigger trial, we could adjust our cheese recipe, lots of stuff we could do, but we're not 95% sure that our cheese is better than the Cumnall cheese. Boom, complete hypothesis test. We're like 80% sure our cheese is better, but we're not 95% sure our cheese is better. Cool. I hope you get that. This is the hard method, okay? This is called the critical region method, but yeah, this is the harder method, but it's kind of easier for your brain. What I'm going to do now is the exact same question again on the easy method, okay? And you're going to like this. You always have the options. If you want to do this way, it's cool with bounding it and figuring out what you'd reject and what you'd accept. But there's a shortcut. You guys ready? Boosh, here we go. Same exact question again. This is the probability method. Okay, so exactly the same. So I've just written this up ahead of time, but there's x, there's blah, 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 blah. It's exactly the same, right? Just without any of the workings out on it yet. Okay. Now, if you want to try the other method, which is a good method also and faster, way faster, it said that 4 people preferred the Chesley cheese. Okay, well, here's what we're going to do then, buddies. All you have to work out is this. you're going to see that either 4 is here or 4 is here. Okay? 4 is either inside our acceptance region. 4 is either inside the green. If the 4 is inside the green, further right along, it means that we do have sufficient evidence to think that our cheese is better. If it's on this side, then we don't have sufficient evidence. So it's the exact same thing, but check this out. You can one-step it. Let's calculate it. What is the probability that x is greater than or equal to 4? And look, all I've done is I've nicked this number and I'm calculating with it rather than worrying about bounds. No trial and error now. Well, if x is greater than or equal to 4 is 1 take away the probability that x is less than or equal to 3, which we just did in the calculator, so I'm just going to steal it. So big calculator, little calculator, it's not 0.186. 186. So the answer to it is not 0.186, which, my lovelies, is bigger than 0.05, which means 4 is here, which means 4 is here, because the area surrounding 4 was this whole area, this blue, and this blue had an area of 0.186. So it's bigger than 0.05, which means that blue's not in the green area, it's inside the other area, which leads us to the exact, and literally that's the only calculation. So we've just shown that 4 is not inside the critical region, so that's all you gotta do. So H0 is accepted, H0 accepted, not 95% sure, not 95% sure, not, how about, I've got a better way, not sure to the 5% significance level, 5% significance level, that our cheese is better. Okay. Now, this method is much faster. If ever you have an opportunity to use this method, which you will a lot, I would probably suggest just doing this probability method because it's faster. Like, you just look at what the answer is supposed to be, 4, calculate its probability. If the probability then is less than the significance region, then that means that well, you did have evidence. If it's more than the significance region, then you don't have evidence for your claim. So I'm going to give you just a ton of time to practice now. Either of these methods is cool. If you feel more comfortable with this at the start, try a few of these, but do make sure that you try it this way as well, because it is faster and it'll help you next year when you go into normal distribution and stuff next year. It'll still help you. So here's what I'm going to get you to do. Page 106, questions 7 to 10. So these are all the wordy ones, like this Chesley cheese question. 7, 8, 9, and 10 are all wordy, so start with them because they're a bit harder. And then 2 to 6 should be like bish, bash, bosh. Go through them. There's some weird stuff in 2 to 6 though as well, so they're kind of interesting. Yeah, so that's what you're going to do. So I hope that's okay, buddies. If you have any questions, please just pop them to me at Show My Homework, and I will try to include answers to common questions on the next video. And that's it. See you later. Bye, lovelies!